Okay, so we will proceed. So in the previous class, we have gone with the basics of operational amplifier and what is ideal and what is non-ideal. That is practical one in terms of different parameters, input and output resistance and gain. We have seen the operational amplifiers. So next we will see is how we can use this concept of virtual ground and virtual sort that we have seen in the previous class to implement the inverting and non-inverting amplifiers. So if an inverting amplifier is there and a non-inverting amplifier is there, how we will be proceeding with the analysis. And also we have seen in the previous class like what is the feedback, what is the effect of feedback on the operational amplifiers. So we have seen there are two different type of feedbacks in operational amplifiers. So before that we will just recap the previous. So before the feedback, the operational amplifiers were analyzed at open loop circuit, open loop operational amplifiers at op-amps, open loop op-amps. Okay, so open loop op-amps we can just see. So this is negative and this is positive. This is V2 and V1, and it was having some gain. Okay, and this gain was nothing but the open loop gain. Okay, and this open loop gain will be different based on, like, if it is an ideal one, this would be infinity, and if it is practical one, it will be close to 10 power 6. This is the case of ideal and this is the case of practical, and here this is the output. And with respect to that, whatever input is there, so input will be the difference of these two. So this will be the input. With respect to that, we were getting the output. So output is, if it is an ideal one, the output will be either plus V set or minus V set. And this is your input and this is your output. So input is the difference of these two. So this was we have seen. And in case of practical, if it is a practical operational amplifier, it will be linearly increasing and then becoming a constant. It is linearly increasing in the negative direction also, then it will become constant. So this was the analysis in case of open loop operational amplifier. So open loop operational amplifier, V output was the gain multiplied by V input. Okay, this is your gain and this is the input, or we call it differential input basically. So between these two terminals, whatever the input we have applied, difference of these two will be input voltage. So this was the case we have seen. So here the output will be either plus V set or minus V set if the input. So if we are applying the input, so if the input is between this range, then in case of practical, the output will be any of this. It will be linearly dependent. Okay, based on the gain. If the input that is applied is beyond this region, that means input lies in this region or in this region. So if it is in this region, it will be plus V set output. In this case, it is minus V set. This was the open loop analysis we have seen already. Okay, so next we will see the closed loop. So in closed loop, operational amplifiers also we have seen, like, we need to have a feedback so that operational amplifiers can be used for high frequency applications, because at that time the gain will be less if we are going to have a negative feedback. So there are two different type of feedbacks we have gone with. So one is negative feedback, another one is positive feedback. So in the negative feedback, we have just concluded, like, the closed loop gain will be very less than the open loop gain. So open loop gain is either infinity in case of ideal one. If it is practical, it will be close to 10 power 6. Okay, we have seen this. So that means in case of negative feedback is there, the negative feedback will reduce the gain. So that negative feedback, in the negative feedback, that is in closed loop circuit, in the negative feedback, the gain will be very less than 10 open loop gain. So open loop gain, we know for a practical case it will be 10 power 6. So with respect to that, this gain will be very less. That means it will be close to like 10. We are just analyzing. So if this is the comparison between open loop and closed loop gains in case of negative feedback, then we can see from here, if we compare 10 and 10 power 6, we can say like in this case open loop gain, that is equals to 10 power 6, is nothing but the AV, that is infinity. That means with respect to them, 10 power 6 is very high. So that's why here open loop gain can be considered as an infinity, or we can call it like open loop gain can be considered as an infinity. If the gain is considered to be infinity, then we can see here like we have seen the virtual short concept or virtual ground concept. So if this condition meets, like the closed loop gain is very less than the open loop gain, in that case the open loop gain can be considered as infinity, so that we can apply the virtual short concept. So we can apply this virtual short concept or virtual ground concept. Okay, or we can call it like this will be concept will be a valid point. So while analyzing the circuit, if this condition meets, we will be able to use virtual ground or virtual short concept. Similarly, in the other case, here if it is positive feedback, the closed loop gain in case of positive feedback will be very high compared to open loop gain, because if it is positive feedback, the gain will be in the case of circuit with the feedback, the gain will be very high compared to open loop gain. So if the comparison will be like, it will be of order of 10 power 11, and closed loop open loop gain is 10 to the power 6 is there. Okay, so in that case, with respect to these two values, by comparing these two values, we can call it like the closed loop gain can be considered as infinity comparison to open loop gain. So if this was the concept in case of positive feedback, so here we cannot assume, so here we cannot assume AOL to be infinity, or open loop gain cannot be considered to be infinity even if it is 10 power 6 only. In these two considerations, here 10 power 6 is there and this was considered as infinity, but here it is 10 power 6, but comparison to closed loop gain, it is very less, so it will not be considered as infinity. Okay, we cannot assume this as infinity. So it is implies like now the virtual short and virtual ground concept that we are going to use in case of negative feedback circuit, we will not be able to use virtual ground or virtual short in case of positive feedback circuit. So we can conclude like virtual ground or virtual short is not valid when positive feedback is there. So while analyzing any circuit with a negative feedback, and if it is satisfying the condition like the open loop gain is close to infinity, or it is very high compared to closed loop gain, then we can use the concept of virtual grounded short. So for analyzing the operational amplifiers that are inverting and non-inverting, we will be going to use this concept of virtual grounded virtual short. Okay, so based on that, we will analyze the first case that is inverting amplifiers or inverting operational amplifiers. Okay, so in case of inverting operational amplifiers, so there will be a feedback that is called negative feedback. So we will be having an operational amplifier. This is negative and this is positive, and there will be an resistance connected with input voltage. So this is input voltage. Suppose input voltage is our Vs or source voltage, whatever. So input voltage is connected to negative terminal with a resistance R1, and there is a feedback and this feedback is the having resistance called RF, that is feedback resistance, and here we are having the output. Okay, and the non-inverting terminal is connected to ground. If this is the circuit, now we need to analyze this circuit. Okay. So from there we can see if it is having the gain, that is AV. Okay, and also we will be considering like as AV in this case will be very greater than the closed loop gain. Then from the above concept we can see like then we can apply virtual ground or virtual short concept. Okay, so if we are able to apply virtual ground and virtual short condition, so what is the meaning of this? So here this is the terminal. Suppose this is the voltage called Vp, that is positive, and this is the voltage at this point is Vn, that is negative voltage. Okay, Vn is there. So if we are able to apply the concept of virtual ground or virtual short, then we can write like the Vp will be equals to Vn. So this is called virtual short. So these two terminals will be considered as short if the condition is met by like this, like the gain is open loop gain is greater, very high than the closed loop gain. If this is the condition, we can apply this. But here from this circuit we can say like Vp is equals to 0, then the Vp is equals to Vn is equals to 0, then we can say like it is virtual ground concept is applied. So by virtual ground concept we can apply like, so whatever voltage is here, the same voltage will be here. Okay, and also if we are considering like AV is very greater than the closed loop gain, in that case if we also consider like the input resistance between this operational amplifier, these two terminals is infinity, that means if input resistance between these two terminals is infinity, here resistance is there and this resistance is very high, like infinity. So then it is behaving like an open circuit. So whatever current is flowing, suppose this is the current I2 and this is the current I1. So if it is an open circuit, there will be no current flowing through it. So another point we can assume like the I1 will be equals to I2 and it is equals to 0 if R input is equals to infinity. If this is the condition, these 2 points we can conclude. Okay, so from there now we need to analyze the circuit. So suppose the initial current it is I and the current in this RF resistance is IF, if this is the current. So at this point Vn we can use the KCL So at this point, at this node Vn, we can use the KCL. So by KCL, we can get like the input current, that is at this node input current is this I, will be equals to two different currents that are out. So one is I2 going inside and another one is IF. Okay, but the I2 we have just seen I2 is equals to 0. So we can write now like, so I will be equals to the current between these two will be, the current direction is from Vs to Vn. So current is flowing from here to here, that means from high to low voltage. So this is Vs is high and Vn is low. So the difference between these two will be giving out the current through this resistor, the voltage across this resistor, and by dividing the resistance we can get the current. So it will be like Vs minus Vn divided by the resistance, that is R1, will be given by the I current, and this I2 is 0 plus IF. So similar is we can find out the IF current. So here current is flowing from Vn to V out. That means this Vn is at high voltage and V out is at low voltage. So from Vn to V naught, that means Vn minus V naught divided by RF will be the IF current. So it will be Vn minus V naught divided by RF, that will be the IF current. Okay, so we can just analyze from there, and we know the the Vn is also equals to 0. So we can just proceed directly like Vs minus 0 divided by R1 will be equals to 0 plus 0 minus V naught divided by R. So it is nothing but Vs divided by R1 will be equals to minus V naught divided by R. So from there, if we find out the V naught by Vs, that is output divided by input, will be equals to minus Rf divided by R1. So this V naught divided by Vs is nothing but the closed loop gain. So the closed loop gain in case of inverting is given by minus Rf by R1. So this analysis is called the approximate analysis. Approximate analysis means whatever the closed loop gain we have got is by considering the different assumptions, like this is considered to be assuming Vp is equals to Vn. That's why this closed loop gain that we have founded, that is minus Rf by R1, is considered to be the approximate analysis or approximate value. This is by approximate analysis. Okay, if we want to have the exact analysis, suppose we want to have the exact analysis, so the same circuit we can analyze exactly also. So by analyzing exactly means we are not going to consider the virtual ground concept. Okay, so in that case we will be saying like Vp and Vn are different, they are not equal. Okay, if this is the case, then we will be saying how the analysis can be done. Okay, so we can do the analysis by considering the other like exact case also. So we are not able to concluding like, so here the closed loop gain is closed loop gain that we are getting was less than the open loop gain, but we are not going to assume this. Okay, so we are not assuming this. So if we are not assuming this, then we are not going to use virtual ground or virtual short concept is not used. We are not going to use this. Okay, so if this is the case, then in case of operational amplifier, we have seen the input voltage of this operational amplifier is considered to be the voltage between these two terminals. So this is the input voltage. So by using this, the input voltage for the exact analysis will be the Vp minus Vn. We have seen this already. And with respect to that, the output voltage will be the gain multiplied by the input voltage. Okay, and here the gain we are considering is that is positive gain. That means it is having some value that is greater than 0, and that's greater than 0 is not 10 to the power 6. Okay, if it is 10 to the power 6, then we will be doing the approximate analysis. If gain is very less, okay, then we will be doing the exact analysis. In that case, this will be the considered. Okay, so by putting the value of V input, we can say like VAV multiplied by Vp minus Vn. Okay, and also Vp by using the circuit, that is the voltage at this Vp point is equals to 0. Okay, so by putting here, we can get like V output is equals to minus of AV into Vn. This is the case if we are putting the value of Vp. Okay, so now we need to analyze the concept of KCL again. So by KCL, again we will be considering the currents that is going to flow. So the current going to flow is I is equals to I2 plus IF, we have seen. So again in this case, I2 will be considered as 0 only because there will be no current. Even in the practical case also, whatever the operational amplifier we are having, the I2 is and I1, that is current inside the operational amplifier, will always be 0. Okay, so this is the case when input resistance is very high. So in case of operational amplifier, the input resistance will be very high, and then I1 and I2 will be 0. So in this case, the I2 will be 0. So we will be applying the KCL. In that we will be representing the I. So I will be represented by the current. So in that case, we are considering like the Vs minus Vn divided by R1, and Vn we have assumed 0 because of the virtual ground, but this time we will not be assuming it 0. So that will be equals to 0 plus If will be nothing but the Vn minus V output divided by Rf. Okay, so this was the case. So now from there, we are not going to assume Vn is equals to 0. We will be having like Vn is not equals to 0. So now we need to just separate the terms of Vn and Vs and V output. So we will be taking Vn outside, and if we transfer this Vn this side, so from there we can just assume or we can transfer this Vn to that side. Okay. So here Vs divided by R1 and V0 we can transfer here. So it will be V0 divided by Rf will be equals to Vn taken outside. It will be 1 by Rf plus 1 by R. Okay. This is how we can do this. Okay. So next point from there we can see is, if we consider the analysis Vn, if we do is like if we recall, like we need to just multiply it. So from there Vs into Rf plus R1 V0 divided by R1 plus Rf, and we will be multiplying this, getting the LCM and then find out. So it will be R1 plus Rf divided by R1 R. So these two will be cancelled out, and it will be like Vs Rf plus R1 V0 divided by R1 plus R2. Okay, or from there we can just Vn is equals to Vs Rf plus R1 plus V0 R1 divided by R1 plus R2. So this is the value of Vn. So equation number 3 is there. So this is the value of Vn. Okay. So now by putting the value of Vn in the above equation 2, from there we can get like the V output is considered as like AV. Just a minute. Yes, am I audible to everyone? Hello?
Oh, yes, sir. Yes, sir.
Two, putting the value of, there is some issue with the network. Okay, so we were from the equation 1 and 3 we can get like the V output will be considered as, so from above we can just see by putting the value of Vn from the equation 3 we will be getting the V0 equals to minus AV multiplied by Vn. So here AV, and then we are having the negative, and then Vs by putting the value Vs Rf minus V0 R1 divided by R1 plus R2. So this is the V0. Okay, so by considering this and solving for the value like V0, so from there we will be separating these values and finding the value of V0. So from there we'll just separate it out like V0. From there if we consider, so V0 from there will be like 1 plus, it will be by solving, so will be this one, and then V0 is here, so from there it will be just one step, we will be solving it, so it will be V0 R1 plus R2, and this V0 will be like plus AV V0 R1 is equals to minus Vs RF AV. So V0 we will be taking outside common. It will be like R1 plus R2 plus AV R1 is equals to minus VS RF AV. Okay. So V0 we can get like it will be minus VS RF into AV divided by R1 plus R2 plus AV R1. Okay. And if we find out the V0 divided by input, that is Vs, it will be minus Rf into AV divided by R1 plus R2 plus AV R1. Okay, so this is the final output we are getting, or we can just represent it some easy manner like V0 minus, it will be AV RF divided by R2 plus R1 we will be considering common. So if we are taking the R1 common, it will be 1 plus AV. So this is the V output by V input, or the output divided by input, that is gain. So it will be look your closed loop gain, and this closed loop gain is the exact one. Means there is no assumption of virtual ground is there. So this will be the closed loop gain. So from there we can just see like it is output is negative, and the previous approximate analysis also their output was negative. So negative means we are having the phase, we can call it like the phase is 180 degree. That means whatever the input we are getting, the output will be 180 phase shift of the input. Okay. So in this, if we do the approximate one, so this was the exact analysis. So in that, if we want to have the approximate analysis, that means we will considering like AV, that is the gain, that will be very high than the 1. If gain is very high than 1, if gain is very high, then we will just represent this equation separately. So V0 divided by Vs will be equals to AVRF R2 plus R1. If gain is very high than A1, then we will be writing it AV. So if this is the case, so we will be 1 plus AV will be equal to AV. Okay, so this is the case. But AV is very high, then R1 multiplied by AV will be equals to this R2 will be neglected in comparison to R1 plus R1 into AV. So from there we will just get that AV RF divided by this will be neglected, R2 will be neglected, so it will be R1 into AV. So this is the approximation we are doing. Okay, so if this is the case, then these two terms will be cancelled out. So finally the V output by Vs will be nothing but the RF by R1. So this is what we have obtained in the approximate analysis. So in approximate analysis, whatever the value of closed loop gain we were getting, the same is we are able to get from the exact analysis, and by putting the value like the gain is very high. Okay, so for the approximate analysis we will be considering only when the gain is very high. If gain is very high, then only the approximate analysis will be done. If the gain is very less, then we have to do the exact analysis. So for exact analysis, the formula will be this one. Okay, and for approximate one, the formula will be this one. So this is the inverting amplifier. So next we will see the non-inverting amplifier. So if it is non-inverting amplifier means we are going to have the circuit like this will be our output, and instead of connecting at inverting terminal, the input is connected to the non-inverting terminal. So here the input voltage is connected, and the feedback will be always with the negative terminal or inverting terminal. So feedback will be here. So this is RF, this is R1, and there is no input means it is connected to ground. And here again I2 will be 0, I1 will be 0, and this is your I, and this is your IM. So for again the approximate analysis, we will be doing the approximate analysis. So here this is your AB. So in this case also we are considering the closed loop gain is very less than the open loop gain. Okay, open loop gain here is AB. So open loop gain is very high than this, then virtual ground is valid. This is basically the approximate analysis. Virtual ground is valid, then whatever the voltage is there is VP and this is VN. So both will be equal. VP is equals to VN and VP is nothing but the VS, so it will be valid. And also I1 and I2 will be equals to 0 because R imposes infinity. So we are doing the approximate analysis. Okay, so this was able to do. So now KCL, by KCL we will be getting I will be equals to I2 plus IF, but I2 is 0, so we can get like it will be IF. So now we will be putting the value of I. So I will be nothing but, so this is current going from 0 to Vn. That means this is at high voltage and this is low voltage. So 0 minus Vn, 0 minus Vn divided by R1 will be your I current. Is equals to IF will be here to here. So here this is at high and this is at low. So current action, because it is from here to here, so it is Vn minus V naught, Vn minus V naught divided by Rf. This will be IF current. Okay, but we know Vn is equals to Vp and is equals to Vs. So we will be putting the value. So it will be Vn will be equals to Vs by R1 is equals to Vs minus V naught divided by Rf. This is by equation 1. So from there we will just separating it out. So it will be Vs Rf is equals to R1 Vs minus R1 V naught. So Rs Vf term we will separating it out. So it will be R1 so it will be like Vs Rf minus R1 is equals to minus R1 V naught. Okay, so if we find out V naught divided by Vs will be equals to so this is V naught divided by there is some okay, so that is okay. So here Vn is equals to Vs we have put Vs Okay, so this is basically -1. So this is Vn. So we will be putting it minus Vn, Vs by this. So it is Rf. It will be, this one is minus. This is plus. Okay. So now it is minus again and minus R1 by this. So from there, if we find out the V0 divided by Vs, it will be minus Rf minus R1 divided by minus R1. So from there it is R1 plus Rf divided by R1. So from there V output divided by Vs will be equals to, it is 1 plus Rf by R1. So this is the closed loop gain. There is output divided by input is equals to 1 plus Rf by R1. This is an approximate one. Okay. So this is the approximate one. From there, it is, we can get like this ratio of V output divided by V input is positive value. So it is the phase shift is basically 0 degree. Phase shift is 0 degree. In the case of inverting one, the phase shift was 180 degree. Okay. So this is the approximate analysis. Similarly, we can do the exact analysis also in case of the non-inverting terminal case. So if we are going to suppose do the exact analysis, we will just go with the exact analysis. This is Vn, this is Vp, and this one is current IA, this is IF, and the gain is this, and this gain is very less. So if we are going to have like the gain is very less, means we cannot go use for, so the gain, so we can get from here like the gain, that is open loop gain is there, that is not very high than the closed loop gain. That means less than 10 to power 6, or we can get like it is very less than the 10 power 6. If this is the case, then virtual ground or virtual short is not valid. If this is not valid, means we cannot take Vp is equals to Vn. We cannot take this one. So now we have to do the exact analysis. So for that, we will find out the input. So this is the input. So input voltage will be Vp minus Vn is gain and the Vn. Okay, so this is Vp minus Vn, the gain value. Okay, so by considering this, and also Vp is equals to Vs. So by considering all these points, by these two, we can get like the output voltage will be nothing but the AV multiplied by Vs minus Vn. So we need to find out the Vn value. So if we want to find out the Vn value, this we need to find out. So we can just rewrite the feedback circuit that is there. So we can write it like, so this is our Vn, and this is R1, this is Rf, and this is our V output. So just we have rewritten the circuit. So this is the circuit part, we have rewritten it. So if this is the case, if we want to find out the Vn, so Vn value will be equals to, by using voltage divider circuit, it will be R1 divided by R1 plus Rf into V0. So this will be the Vn value. Okay, so this is voltage divider circuit. So by putting this, we can just get the value of Vn. So Vn value we can put it here, R1 divided by R1 plus Rf into V output. Okay, so this we have got. So from there we will be separating V output and Vs. So V output minus this V output term we will be taking here that way. So it will be AV R1 V naught. This is minus plus will be there, and R1 plus Rf is equals to AV into Vs. AV into Vs. This we have taken that way. So from there V naught will be equals to, we will be separating it out. So it will be 1 plus AV R1 divided by R1 plus Rf is equals to AV Vs. So from there V output divided by V input, that is Vs, will be given by AV divided by 1 plus AV R1 by R1 plus R. So this is what we can get in case of exact analysis. Okay, so we are doing the exact analysis, then this is the point we can get, or we can rewrite it like AV divided by 1 plus R1 by R1 plus Rf multiplied by AV. So here this R1 divided by R1 plus Rf is considered as the feedback factor here. So this is considered as the beta is equals to R1 divided by R1 plus Rf is equals to feedback factor. So this is coming out to be in case of exact analysis. If we want to apply this gain value, so if the gain that we are considering, if this gain suppose is infinity or very high, then what will be the V output divided by Vs, we will see. So if it is infinity, so by putting the value we can get like it is infinity divided by infinity. So we can get a value exactly of V naught divided by Vs. So this is your closed loop gain value. Okay, so it is infinity by putting the AV equals to infinity. So we need to find out by using the limit theorem. Okay, so for that consideration we need to consider like limit AV tends to infinity, V output divided by Vs, that will be limit AV tends to infinity, and the value is like AV divided by 1 plus R1 multiplied by the AV. So as we need to put AV equals to infinity, so what we need to do is divide both sides, numerator and denominator, by AV itself. So it will be limit AV tends to infinity 1 by 1 plus AV plus, this is R1 by R1 plus Rf, by dividing both the sides by AV. So this will be 3. So now we will be putting the value of AV. So AV is equals to infinity. So 1 by infinity will be equals to 0. Okay. So this term will be coming out to be 0 by putting the value. So next we will write like 1 divided by 0 plus R1 by R1 plus R. So that will be our V naught divided by Vs by putting the limit equals to infinity. So it is V naught divided by Vs will be equals to this one. So it is going upside. So it is R1 plus Rf divided by R1. So that is equals to 1 plus Rf by R1. So that is the closed loop gain with approximate analysis is V naught divided by Vs is equals to 1 plus Rf by R1. So this is your approximate analysis that we have done initially. Okay, so in case of inverting and non-inverting case, we can do the exact and as well as the approximate analysis. So basically, in case of like if it is given like the operational amplifier is an ideal one, we will be taking the approximate analysis always. Okay, and if the gain is very less given, like it is given 10 or 20 AV, that is open loop gain is given 10 or 20, we will be using the exact analysis. Okay, so this is the basics of inverting and non-inverting amplifiers. Okay, and one more term, sometimes in objective type questions it is given like what is the percentage of error. So sometimes percentage error is asked in even gate and even some PSU type questions, objective type questions. So error is asked, so that error is given by like what is the exact value of gain. Okay, exact value of gain in case of with negative feedback, inverting non case, minus the approximate value of gain divided by the exact value of gain multiplied by 100. So this will be giving out the percentage, like what is the percentage error is there in the calculation of gain. Okay, so this is how we will be doing the analysis in case of inverting and non-inverting amplifier. So if there is the case like both the inputs are applied with some voltage, that means that configuration of operational amplifier will be called as differential amplifier. We are having the input at both the terminals, that will be differential. So in that case, we will be getting the analysis by utilizing the superposition theorem. First of all, we will be considering one input, another one we will make it 0, and similarly the second case and the first one will be considered as 0. So by superposition and applying the inverting and non-inverting concept, we can get the value of gain. So from there we can get the value of output. So this is all about the operational amplifiers that is connected in inverting and non-inverting modes. So if you have any doubt, you can ask. Otherwise, we will close the class. So till now, anyone is having any doubt? Okay. If you don't have any doubt, then we can, yeah. So we can close the class. And also I will be uploading the assignment of for unit 3rd. So just go with it, and you need to solve the assignment and upload the scanned copy. Okay. So thank you.
Okay. Thank you, sir.